Hi. So we'll be starting off with the chapter Time and Work today. Okay. Time and Work has been one of the most prime chapters, and you would always see around two questions in every paper. Two to three, no, won't be two to three, but definitely one to two questions in every exam that has been conducted by SSC or other competitive exams. So, what are we looking at? What are we looking at? Time and Work is a concept, or it's a chapter in which or more people two or more people get involved in some work, and we have to determine the time that it takes to finish the work. Okay, it is as simple as that. As simple as this statement is, the chapter is also that simple. You only have to understand three concepts, three or four concepts. The first one being the LCM method, the second one being basic proportionality method, the third one being linear equation method, linear equation method, and the fourth one, I'll come to the fourth one. This is the LCM method, the basic proportionality method, and the linear equation method. So, yeah, I think I should rather call it the efficiency method. Efficiency method. Okay. So, what happens in LCM method is that two or more people are working. Let's assume A can finish a task in 10 days and B can finish a task in 15 days. Okay. So, when they together get onto the task, how much time it's going to take them to finish the task? If we try to find out the contributions of A, the contribution of A for every 1 day is 1/10. For every 1 day, the contributions are 1/10. And for B, for every 1 day, the contributions are 1 by 15. Okay. So when I add all of them up, 1 by 10 plus 1 upon 15, then I have to solve this. When I have to solve this, what do I do? This is equal to 1 upon total work. This is equal to 1 upon total work. And I have to solve this particular equation. Got it? So what happens in the LCM method is, here you will actually have to take the LCM and solve this equation. But what we prefer and what we recommend to our students is that whenever A and B are, let's say, assuming that they are taking 15 days, 10 days and 15 days to finish a task, we'll quickly find out the LCM. The LCM to 10 and 15 is equal to 30, right? Then 30 upon 10 is equal to 3 and 30 upon 15 is 2. So I can clearly say that the work or the total work unit is equal to 30, and it's going to be finished by the help of 3 and 2 efficiencies. These 3 plus 2 make up to be 5, and 30 upon 5 is nothing but 6. So the total work is going to get finished in 6 days, right? Cool enough. Now talking about basic proportionality, or let's first talk about linear equation method. So what happens in linear equation method is that there is a concept of and or. Okay, there's a concept of and or. What happens over here is that the work is being done in groups. What kind of groups? We can say that there were two males and three females. We can say that there were three children plus three women plus two men. Okay, so the work is being done in groups, and the question says it very clearly and very straight away. I'll tell you how. The question says that two men and three women together can complete a task in, let's say, 15 days. Similarly, if I employ three men and two women, then the task can be finished in 10 days. Okay. So whenever this kind of an equation comes in, you have to follow the linear equation method. What does the linear equation method says? There is supposed to be an equal sign between the two situations. Whatever situation is on the left stays on the left, and whatever situation is on the right stays on the right. Okay. So this entire situation of 2 men and 3 women working together is one situation, and this entire situation where 3 men and 2 women are working together is one situation. Whatever time they take together is multiplied there itself. Okay, see, as you can see, 15 is here itself, and is whatever time is spent by 3 men and 2 women, this also stays in the same place, which is equal to 10. Okay, this stays on the same side, it doesn't switch sides, it stays on the same side of the equal to sign. Okay, so this is the linear equation method. What do we get out of the linear equation method? I'll tell you what we get out of the linear equation method. Firstly, let's quickly solve this. It says 30 men plus 45 women is equal to 30 men plus how many? 20 women. Okay, so this is a classic case of me committing a small blunder. Okay, so this is 3. Let me call it 4. Okay, 4 men. Let me call it 4. So I have 40 men over here. I have 40 men over here and 20 women over here. So the 30 goes here. This creates 10 men. And 20 goes here. This creates 25 women. So men upon women comes out to be, yeah, 5 upon 2. So this value of 5 upon 2 is nothing but the efficiency of each of them. What is the efficiency of men, if you may ask me? The answer is 5. What is the efficiency of women, if you may ask me? That is 2. Okay, I hope you are able to understand. 5 upon 2 means men upon women. Now, taking it forward, if somebody asks me what is the total work that is supposed to be done, so what I'll do is I'll replace the value of m is equal to 5 in the first equation, any side of it. You can take the left side or the right side, and you can replace the value of women as 2 in the first equation itself. Then when you solve it, when you solve for one side of it, you get the total work. Then the total work upon total people involved, or the total time being, or the total work being done in one day, that will give you the number of days. It's as simple as that. Okay, so there's also something known as the efficiency method. Let's assume that we have to take a trip from Delhi to Sri Lanka. Let's say the airline company A takes 10 hours to reach, and the airline company B takes 7 hours to reach from Delhi to Sri Lanka. So, this is the time that they are taking. When I talk about efficiency, when I talk about efficiency, and I have two situations with me, the efficiency is always inversely proportional to the time. Okay, the efficiency is always inversely proportional to the time. Why does it happen? I'll tell you. If somebody is taking a longer time, if somebody is taking a longer time to solve something, that means that the person is slow. That means the person is a little less efficient. So, whenever you see a situation where a person is taking longer time as compared to the other guy, that means he will definitely have a lesser efficiency than the other guy. So, if time and efficiency are inversely proportional, I can quickly apply a cross multiplication technique and bring the efficiency of A equal to 7 and the efficiency of B equal to 10. You would tell me that the time that B is taking is less. How is he getting better efficiency? My answer would be somebody who finishes their homework as soon as they reach home, or as soon as, or even before taking their lunch at home, are the ones who do well. They are also called efficient students. So, in this situation, the values or the figures speak for themselves. They are very clearly saying that B is having a higher efficiency as compared to A. Why? Because B is taking lesser time to finish a task. So this is the efficiency method that we're talking about. Okay. Time is always inversely proportional to the efficiency. I've also talked about about the linear equation method and the basic proportionality method. I'll tell you during the course of the lecture. Okay. This is nothing but a simple point where I'll talk about MDH. Okay. MDH is one of the most popular masala making or masala. But what do I mean by masala? Masala is nothing but a concoction of different spices. Okay, so MDH is a company. MDH is equal to MDH. This is a small lingo for a formula which I have made, and this is not a great invention or something. This is just my way of saying it. Okay, MDH is equal to MDH. If two parties are doing the same work, if two parties are doing the same work, then the men in the first party multiplied by the days the first party is allocating to the work multiplied by the number of hours the first party is taking every day should be and must be definitely equal to the multiplication of men in the second party, the number of days in the second party, and the number of hours in the second party. Got it? So this is equal to these two equations are completely equal. Then I also introduced another variable that the complete work being done by M1 D1 H1 can be called as work 1. Similarly, the complete work being done by M2 D2 H2 can be termed as work 2. Okay, so this is the basic proportionality concept that we are talking about. Similarly, the concept 1 which you read over here, which I never talked about, what do I mean by that? I mean to say that number of persons in the first party multiplied by the number of times or the number of days the first party is taking is equal to the multiplication of the number of people in the second party and the number of days being taken by the second party. Okay, so the entire equation is balanced, it's very well balanced. Moving on, 21 typists complete a project in 8 days. In how many days 15 typists will complete the project? The work is the same. I'll quickly apply the MDH method. Okay, this is M1 D1 H1. Okay, is equal to M2 D2 H2. Work 1 is being done by the first party, work 2 is being done by the second party. The work isn't different. Okay, the work is the same, so the work will get cancelled out. There is no concept of hours. There is no concept of hours, so the concept is also going to fade away. Okay, so what do I have? Men 1 day 1 is equal to men 2 day 2. So I have 21 typists on day 1. Sorry, I have 21 typists in party 1 multiplied by the 8 days that they are spending together to finish the task is going to be equal to the 15 typists that are there in the second party and should be multiplied by the number of days that the second party take. I'll quickly solve it. 3 5s are 15, 3 7s are 21, 7 8s are 56, 56 upon 5. The answer comes out to be 11.2 days. Okay, the answer comes out to be 11.2 days. Yep, good enough. Moving on. A alone can complete half of a work in 150 days. In 50 days, what is the percentage of work? In 50 days, what percentage of the work will be completed by A? So, A is doing half of his own strength or half of his own job in 150 days. See, this is again basic proportionality. A is doing half of his job in 150 days. How much time will A take to complete his entire one job? This is equal to 300. Pretty logical. Very standard concepts of basic proportionality theorems, right? So basic unitary method. Okay, so A by 2 is equal to 150, so the value of A is equal to 300. The total work alone can be done by A in 300 days. This has been established. Now if somebody asks me 50 days is the time that A is working, tell me how much work he would be completing. So the portion of work that he is doing divided by the full work that he has to do multiplied by 100 would give me the percentage of work being finished by A. So the portion that he's doing is that of 50 days. The full work takes 300 days to complete. When I multiply it by 100, this would give me the percentage. 3 16s are 48.66 is the answer. So 16.67% is my final answer. Right? Good to go. Moving on. Moving on to the next question. Yep. So the question is, I'll talk about the concept. You remember I taught you the MDH concept? The MDH concept in the basic proportionality. What happens is, same place here also the same thing has been talked about. It says when person 1 is working for time 1 and the same work is done by person 2 in some time 2, then person 1 and time 1 is doing work 1 and person 2 and time 2 are doing work 2. So this is it. This is nothing but the same. MDH is equal to MDH. Okay? MDH is equal to MDH. This is the same thing. It's not at all different. So I'll move to the question quickly. Adish can complete a work in 14 days. If he worked for 8 days, then what fraction of the work should be left? 8 days was the work that he has done. If the total work was that of 14 days, the gap between 8 and 14 is 6. 6 is the work which is pending out of that of a total work of 14 days. So 6 upon 14 multiplied by 100. See, I don't think the 100 is required because it's saying what fraction of the work should be left. So I'm going to remove this. Simply 6 upon 14. 2 3s are 6 and 2 7s are 14. My answer to this question would be 3 upon 7. Okay. The answer to this question would be 3 upon 7. Moving to the next question. 36 equally efficient workers can paint 25 identical walls in 48 days. I'll first find out the answer for you and then teach you the method which I have taken. Okay. So 36 multiplied by 48 and the output is 25 identical walls. Okay. In how many days can 45 such workers multiplied by time 2 whole divided by 60 such walls? Okay. I'm going to write it again 60 such walls. I'll quickly solve it. 9 5s are 45. 9 4s are 36. 5 12s are 60. Yep. So this is going to be 12 into 48 into 4 whole upon 25. To remove this 25, I'm going to multiply 4 in the denominator and 4 in the numerator. This would give me 100. Now, I'll first multiply the big numbers, okay? 4 4s are 16 and 16 into 48. That's what I'm going to do first. I'll quickly tell you the sequence. Whenever you have big numbers to multiply, always start with the bigger ones, okay? So we have 16 into 48 into 12 upon 100. 16 8s are 128. 12 in balance. 16 4s are 64. 64 plus 12 is 76. 768. 768 multiplied by 12 whole divided by 100. 12 8s are 96. We have 9 in balance. 12 6 are 72 and 9 is 81. 12 sevens are 56. 56 plus 8 is 64. So 6 4 no 12 sevens are 84. 12 6 is 72 plus 9 was 81. 12 sevens are 84. 84 plus 8. 84 plus 8 is 92. This is not this is basically 92.16. Okay. So we have the option B, 92.16 as our final answer. I've applied the same formula. I've applied MDH is equal to MDH whole upon work 1 whole upon work 2. In my formula, there was no relevance of these 25 identical walls. In my formula, there was no relevance of these 25 identical walls because it was neither fitting men, it was neither fitting days, it was neither fitting hours. The only place it was fitting was the work. It was the work. And how come the work of the walls is comparable? The reason is very simple. because firstly 36 men were painting walls. In the second case also 60 workers were painting walls. No, 45 workers were painting walls and there were 60 walls. So walls were being painted in the first case and walls were being painted in the second case. That is why I can designate wall painting to be a job. Okay, I can designate wall painting to be a job. That is why wall 1 and wall 2, or I should say work 1 or work 2. Okay, that is why it came in the denominator. I hope I've made myself very clear with this. Okay, moving to the next question. Now, I have talked about in the first slide, I've talked about linear equation method and or method, where you have group of people working together. When group of people work together, you have to create simple linear equations. Whatever is said in one sentence should stay on one side. Whatever is said in the next sentence should stay on the other side of the equal to. Right? So I'll quickly do it. Yep. 10 men or 15 women. This is not woman, this is woman. 10 men or 15 women can complete a work, again a W problem, okay? Can complete the work in 30 days. In how many days can 15 men and 27 women complete the work? Okay. So firstly, the only thing that we have to reach is the ratio. The only thing that we have to reach is the ratio. And ratio of what? The ratio of the efficiencies of men and women. Men and women, and that too separately. That too separately. This is very important. Okay. Separately. That too separately. So what I'll do is I'll read the question again and tell you what's going on. There is a concept of or in the middle. There's a concept of or in the middle. I'll teach you the concept of or first. When there is a concept of or, there is automatically a sign of equal to between the two parties, party 1 and party 2. Whenever there is a sign of and, that time you have to work in this setup where party 1 is there and plus party 2 is there. This would be equal to, let's say, party 1 plus party 2. The only difference would be that the number of parties, let's say here it is x and y, the coefficients of the number of parties may be k and p. Okay, it can be different. So I'll come back to the question. 10 men, I'll come back to the question. We have 10 men or 15 women can complete a work in 30 days. 10 men can complete a work in 30 days is equal to 15 women. They can also complete the work in 30 days. Right? So I'll quickly solve it. From here, 30 gets cancelled with 30. 5 twos are 5 threes are. M upon W is equal to 3 upon 2. This is my first equation, and this equation will solve my entire question. Okay? This equation will solve my entire question. How would it do that? Now I have the efficiencies of men and women. I know they are relative in nature. I know there is a ratio element involved, but for the time being, we will have to clearly assume that the efficiency of men is 3 units and the efficiency of women is equal to 2 units. Cool enough? Men and women 3 and 2. Now, wherever you find the variable m written, you can replace it with 3. Wherever you find the variable w written, you can replace it with 2. That would give you a concrete and a numerical work, which is our total work. Let me first find out the total work. In the first instance, we created a small equation where we used the concept of or and defined what efficiencies men and women would take up. Now, 10 men multiplied by 30 is the total work being done by men, which is also equal to 15 women into 30. Now, I can take up any of the works, be it of that of men or be it that of women. Let me take the work of women, 15 women 30. This is the work which is done by women. So 15 multiplied by 2, which is the efficiency of women, multiplied by 30. This becomes the total work being done. Okay, this becomes the total work being done. I hope this is very clear. Some people might tell me that no, we wish to take the work of men. But the reality is, men and women are doing the same work. No matter who you pick up, the output is going to come out to be the same. I'll tell you how. Let me pick up the work of men. The work of men is that of 10 men into 30. I'll pick up the efficiency of men. What is the efficiency of men? The efficiency of men is 3. So 3 multiplied by 10 multiplied by 30. This gives me the output of 900. I'm marking it as the answer. Okay. This is not the final answer. This is the answer in the middle. Here also, the answer or the total work comes out to be 900. So it doesn't matter whose work you pick up. You just have to pick up one side of the equation. Also, do not cancel out anything while calculating total work. Okay? Do not cancel out anything while calculating the total work, because it will not help you. Because it will not help you, it will give you the answer which is lesser. So never do that. I did not I did not assume that 30 and 30 is cut off and 10 men is equal to 15 women. No, you're not supposed to do it. Whenever you're finding total work, always use the original raw equation. Okay? This over here is the raw equation. Always use the raw equation to find out the total work. Now, in how many days can 15 men and 27 women complete the work? I have the numerical value of total work being 900 units. Now I need to find out what capability do we have. What capability do we have? The capability we have is 15 men plus 27 women. 15 men plus 27 women. 15 men means 15 multiplied by 3 plus 27 women means 27 multiplied by 2. 15 threes are 45 and 27 twos are 54. What we have here is 99. So 99 is the capacity, or 99 is the power with which I can work on a daily basis. On a daily basis. So 99 units of work can be done in one day. The total work is 900. When it is divided by 99, we get the answer as 100 upon 11. This means my answer is 9 1 by 11 days. So when 15 men and 27 women try to complete the work, they are going to take 9 1 by 11 days to complete it. Right? Got it? Let's move on. If one man or two women or four boys or five girls can finish a work in 39 days, then how many days will one man, one woman, one boy, and one girl together take to finish the same work? This is a very similar question. I'll quickly jump onto it. One man or two women or four boys or five girls. Whenever we are talking about or, we can directly put out equal to in middle of everywhere. Okay? One man is equals to two women is equal to four boys is equal to five girls. And all of them are taking 39 days. All of them are taking 39 days to complete the task. So there is a problem that I can see over here. The problem is, there we could easily say that men is equal to women in the last equation, and the efficiency of men was 3 and the efficiency of women was 2. And we could easily find that out because, let me rewrite it, men upon women is equal to 3 by 2. We could easily find that out. Why? Because there were only two variables involved. Right now we have four variables involved. This takes me back to the place where I taught in ratios that whenever you have more than two variables, you will have to bring out the efficiencies by pulling all the numbers down to the denominator. How is that possible? I cannot say that 1m is equal to m upon 1 or 2w is equal to w upon 2. That is not how it works. All of them are interrelated. I will have to take the LCM of 1, 2, 4, and 5. The LCM of 1, 2, 4, and 5 is 20. So I'll quickly divide everybody by 20. This gives me the value of m, or the efficiency of m as 20, the efficiency of w as 2 because I'm dividing it by 20, and the efficiency of B, or boys, to be equal to that of 5, and the efficiency of girls to be that of 4. Understood? Okay, if you couldn't understand this, we have tried to figure out the efficiencies of all of them without mixing all of them up. And we've used the simple concept of ratios, that whenever you have multiple variables in one line and you need to find out the values of each variable, or the supposed values of each variable, or not the absolute but a temporary value of the variables, you have to take the LCM and divide it by everything, and divide 20 by each and every term. So this is how we get this output. If you ask me what is the efficiency of men, I'll say 20 units. What about women? 10 units. What about boys? 5 units. What about girls? 4 units. Okay? Now, if somebody asks me what is the total work, what is the total work? Now, my total work over here, as it has been very beautifully mentioned in the question, that all of them are working separately. All of them can work separately. So, my total work can be this, my total work can be this, my total work can be this, and my total work can be this as well. So, I can use any of them. What I'll do is I'll use the work of boys. The total work of boys is equal to 4 into B into 39. I'll use the value of B as 5. So 4 into 5 into 39 is my total work. Okay, I am writing it as TW. Right? Now, the question says, then how many days would it take for one man, one woman, one boy, and one girl together? I'll quickly write down their efficiencies right alongside: 20, 10, 5, and 4. When I add all of them up, I get the value as 39. This means that one day's work of the team of 4 people, which includes one man, one woman, one boy, and one girl, is equal to 39. When their total work and one day's work, when this is divided, this gives me the total number of days to finish the work. It means 4 into 5 into 39 whole divided by 39 would give me my output. 39 ones are 39 ones are. We get 4 into 5 as 20, and 20 is my final output. Okay, 20 is my final output. I hope we are good. Pretty good. Moving on. I think this slide is repeated, and type. What about this one? This was 3A, this is 3B. Not much difference. Okay, not much difference. I've already taught you this. I'll quickly move to the solution. 5 men, 2 boys can do in 30 days as much work as 7 men and 10 boys can do in 15 days. Simple linear equation. 5 men plus 2 boys can do a job in 30 days, which is also equal to a job which is done by 7 men plus 10 boys. 7 men plus 10 boys in 15 days. How many boys should join 40 men to do the same work in 4 days. Let me first figure out what is the efficiency of men and boys alone, what is the total work, and then the kind of data which is being asked over here from this area to this area. We are going to figure out this thing in the end. Let me do my basic job first. 5 men plus 2 boys can do some work in 30 days. Similarly, 7 men plus 10 boys can do the same work in 15 days. Cool. So 30 multiplied by 5 is 150 men. 150 m plus 60 b is equal to 105 men plus 150 b. Okay. I'm going to bring 105 here. This makes it 45 men is equal to 90 boys. From here, I can quickly write that men upon boys is nothing but 2 upon 1. 45 ones are 45, 45 twos are 90. So, men upon boys comes out to be 2 upon 1. I think we're good. 2 upon 1, we're good. What I'm going to do now, I have my first equation ready. Now I need to find out my total work. Okay, I need to find out my total work. How would I do that? My total work would come by using either of the two equations, either of the two portions. I'll use 5 men plus 2 boys working together for 30 days. Men's efficiency is 2, boys' efficiency is 1. So I'll put 5 into 2 plus 2 into 1 whole multiplied by 30. I'll quickly skip a step. 5 twos are 10, 10 plus 2 12, 12 plus 12 multiplied by 30 is 360. 12 multiplied by 10 is by 30 is 360. So 360 units is my total work. Okay. And this is my second portion of the journey. Now it's asking me that the same work, 360 work has to be completed by 40 men plus X number of boys, and the work is supposed to be completed in 4 days. The work is supposed to be completed in 4 days. I'll quickly use the values of M and B and put them over here. 360 upon 4 is equal to 40 multiplied by 2 is the efficiency of men plus X multiplied by 1 is the efficiency of boys. So 4 ones are 4 nineties are. So I have 90 being equal to 80 plus X and X being equal to 10. This means, this clearly means that 10 boys are required to work with 40 men to finish the same job in 4 days. Okay, this is my final answer. This is my final answer. Good enough? Let's move on. 4 men and 6 boys can do a work in 8 days, and 6 men and 4 boys can do the same work in 7 days. Then, how many days will 5 men and 4 boys take to do the same work? I won't be explaining much over here. The reason being very obvious that I've already taught you this. Okay. Try to be a little smooth. Okay. Try to solve this question along with me. I'll write 4 men plus 6 boys can do a work in 8 days, and the same work can be done with 6 men plus 4 boys in 7 days. Right. So 8 fours are 32 men, 8 6 are 48 boys is equal to 42 men plus 28 boys. This becomes 10 men and this becomes 20 boys. This brings me to the point where m upon b is nothing but 2 upon 1. My first equation is in my hand. I'll find out the total work. Total work can be dealt with either this side or the other side. It can be dealt with either of the sides. I'll take the left side. 4 men plus 6 boys do a work in 8 days. I'll use the efficiencies here. 4 men means 8, 6 boys means 6. 8, 8 is a 64, 64 plus 48. No, I won't do that. 14 8 is a 8 4 is a 32, 3, and this is 112. So 112 is the total work that is being done, right? 112 is the total work being done. Now, how many days will 5 men plus 4 boys take to do the same work? 112 is the total work. 5 men plus 4 boys wish to do the job. This means 112 divided by 5 men means 10 efficiency, 4 boys means 1 efficiency. 112 divided by 14, 112 divided by 14. So this makes it 8. So 8 days is my answer. 8 days is my answer. Okay. This might be a little faster as compared to the last one. This was my second equation. I used the first and the second equation together to reach the conclusion. Right? Moving on. Now, this concept I haven't taught you when I was talking about the entire chapter of time and work. Let's say that 100 men came together to build a wall in 30 days. After 10 days, a few men left. Let's say after 10 days, 20 men left. So, how many more days it's going to take to finish off the work? I won't be solving this point, but I'll be telling you what the necessary action or what is the necessary thought which should come into your mind whenever you solve this question. Do not run after the 100 men working for 10 days. No, only work after the 100 men whose 20 days work is left. Okay? Do not focus on the work which has been completed. Only focus on the work which is left. I hope you get my point. Only focus on the work which is left. Do not focus on the work which has already been done. Because you don't know how big the total work would become because of people going away. So it's better that you can see, okay, this much work is left. I need to finish only this much. Got it? Whenever people leave, do not think about the ones who have gone back in the past. Only think of the ones who are going to come in the future. Got it? Moving on. A camp of 150 soldiers has food for 400 days. After 50 days, 100 more soldiers join the camp. For how many days will the food last from then onwards? So when there were 150 soldiers, the food was available for 400 days. After 50 days, that means only 100 days food is left, and the 100 days food is left. No, 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 no. Only 350 days food is left, which can feed 150 soldiers easily. Only 350 days food is left, which can feed 150 soldiers. Feed 150 soldiers, right? So this is equivalent to now how many more soldiers have come and joined? 150 plus 100. This is the new set of soldiers which has come and joined. So 150 plus 100 makes it 250. Now I need to say how many days would the food last. Okay. Some work is done on the left hand side. It is supposed to be some work which is done on the right hand side. 350 days are left. 150 people were to be feeded, were in the past, were to be feeded. This is equivalent to 250 soldiers now, and X is the number of days when they are supposed to be feeded, right? I need to find out the value of X. I'll quickly do it. 53 is a 55 is a 570 is a 350. This gives me the value of X to be 210 days. Okay. In the beginning, had there been no new soldiers, the food would have lasted for 350 days. But now, as new soldiers have come into the picture, the food is going to last only for 210 days. Okay? I hope I've made myself very clear. Here, I have talked about what work is left is relevant. Okay? Work left is the only relevant point. Okay? This is the main star point, that work left is only relevant. We did the same thing here. This was the total work. We did not see much of it. We only focused on 350 days and 150 people. Okay, this was the days left and soldiers present. 100 over here were the new soldiers. They were the new soldiers. Good enough. Moving on. 13 men can complete a work in 7 days. 13 men can complete a work in 7 days. After 3 days, 4 more men joined them. How many days will they now take to complete the remaining work? Let's not focus on total work. Total work, let's not focus on this. Let's focus on the work which is left. The work is left is that of 13 men. 13 men are supposed to work only for 4 more days to complete the task. But with the 13 men, 4 additional men have joined. 4 additional men have joined. The 4 men who have joined now are going to reduce the workload, right? 4 additional men will help to reduce the workload, and they might get the work finished sooner. So the remaining work can be done in how many days is the question, which is equal to X that I'm talking about. 13 fours are 52. 52 divided by 17. This is the value of X. When I put it in mixed fractions, 17 threes are 51. Yeah, I'll 17 threes are 51, and 1. This is equal to X. So 3 1 by 7 days. 3 1 by 7 days is supposed to be the time that is going to be the remaining work, right? That is going to be the remaining work. Remaining days, okay? The number of days that I'm going to take to complete the remaining work. See, the concepts are very plain, very basic. The answers come out pretty soon. So, this in this particular chapter of time and work, you must aim for 100% accuracy. Okay? You must aim for 100% accuracy. Do not get any questions wrong in time and work. Moving ahead. When A and B take X and Y days respectively to complete a work, this entire area is going to be based only and only on LCM. Okay? This entire area is only and only going to be based on LCM. What happens with LCM is, on one side we have days, in the center we have LCM, and on the right hand side we get efficiencies. We get efficiencies. In a tad bit advanced version, you would see that somebody quits. Somebody quits. Now there are two ways of quitting. There are two ways of quitting. You work for, let's assume, 3 days and quit. The work would not be completed with you because you left only after working for 3 days. Second way of quitting is work for last 3 days. Last 3 days means assuming three three days before completion. Work for 3 days before completion. I think we are good. We've understood what we're talking about. So there is a difference over here. There is a difference over here. The LCM that we get is nothing but the total work. Okay? The LCM that we get is nothing but the total work. Whenever you form an equation, this is the theory part of it. You will get to understand it much better when we solve the questions. In the theory part of it, you will have total work over here as well. I'll quickly change the color. You will have total work over here as well, total work here as well, and total work here as well. When somebody works for 3 days in the beginning and leaves, at that time, his work, I'm writing, his work is subtracted. When somebody works in the end or 3 days before completion, his work is added. In the most simple ways, what you have to do is you have to subtract the work when somebody works and quits. But if somebody quits after working or just before completion or in the end, at that time you have to add his work. Okay, these are nothing but very beautiful rote techniques. Okay, you need not understand what's happening, you just need to gulp it down. The technique says work for 3 days and quit. That means your work would be taken out of the total work, would be left out of the total work. But if you work for the last 3 days, or you work only 3 days before the completion, or you quit 3 days before the completion, your work would be added. Okay, your work would be added. Now I'll quickly take you through the questions. Param can do a piece of work in 24 days. Charan can do a piece of work in 30 days. If they work together, how much time are they going to take? In this question, we'll very beautifully apply LCM. What is the LCM of 24 and 30? The LCM of 24 and 30 is, let me quickly do it. 720? No, that's a very big number. Let me bring it down to 240. 240 works really well. But if I just do a 120, 60? No, 60 is too less. 120 seems good. How did I come up by 120? Just see. 24 is made up of 8 and 3. So I have 2 into 2 into 2 multiplied by 3. 8 3 is 24. Now I need to accommodate 30 in this. I already have a 3 with me. I already have a 2 with me. I just need one 5. Why? Because 30 is made up of 6 multiplied by 5. Okay? 6 multiplied by 5. I already have 6 with me. So I'll just put a 5 over here. 5 2s are 10. 3 2s are 6. 6 2s are 12. This makes my LCM to be 120. And 120 is the total work which is supposed to be done. These were the number of days. Now I'll talk about the efficiency. If 120 is the total work and P's contribution, Param's contribution is 24, then the efficiency would come out to be 24 ones are 24 fives are. The efficiency would come out to be 5 units. per day. Similarly, if I do 120 divided by 30, 3 ones are 3 fours are, the efficiency of Charan would come out to be 4, 5 and 4. Now, how long will they take to complete the work? Total work divided by total efficiency is my answer. My total work is 120 and my total efficiency is 5 plus 4, which is equal to 9. So 120 upon 9 is my answer. 120 upon 9 in mixed fraction is 9 ones are 9 and 9 threes are 27. 13 nines are 117. Am I wrong? No, I'm right. 117, we are left with 3 and 9. So 13 3 by 9 days is the total time they would take to finish the job. Seems a little boring? Let me give you the ultra shortcut. Let me give you the ultra shortcut. When two people are working together, the number of days they are working needs to be multiplied, divided by the sum of the days. Attack. Finish. How well? Just see. 24 multiplied by 30 divided by 30 plus 24. This gives me 24 into 30 whole upon 54. 6 5s are 30, 6 9s are 54, 3 1s are 3, and 3 8s are 24. Am I right? Am I wrong? No, this is perfectly fine. 30 and 30 plus 4, this is 54. 6 9s are 54, 6 5s are 30. Yes, this gives me 40 upon 3, which also gives me 14, 13 threes are 39, 13 1 by 3 days. Now you'll ask me that, sir, you've done it wrong. Sir, you've done it wrong. But the reality is both these values are same. Both these values are same. What I did here was 120 by 9 could have been cut off once. 3 threes are 9, 3 fours are 12. So 40 upon 3, 13, 1 by 3 could have come here as well. But I can convert 13 3 by 9 into 13 1 by 3 as well, because 3 ones are 3, 3 threes are 9. This makes me 13 1 by 3 days. So my answer is the same throughout. The answer is the same throughout. So this ultra shortcut can be applied very well when two people are working together. There is a possibility that somebody is doing a positive work and somebody is doing a negative work. When I say negative, it means that, let's assume that you are sowing seeds in an entire garden. You are sowing flowers or you're planting new trees in the entire garden, but somebody who is a saint, or let's say the devil of deforestation, comes and cuts off or chops off the trees. So that devil is doing a negative job by cutting off the trees, and you are doing a positive job by planting trees. So whenever there is a possibility, let's say that the saint was planting trees in a garden, and he would have taken 24 days to completely plant, like completely fill the garden with trees. And the other guy, the devil, would have taken 30 days to chop off all the trees. So if both of them work together, how much time would they take? How much time would they take to completely fill the garden? As the saint has a higher efficiency because it is taking lesser time, the garden would definitely be full. Okay, the garden would definitely be full. The only difference would be 24 would be multiplied by 30. But instead of having 30 plus 24, we would have 30 minus 24. Okay, the total work which we are saying is going to happen in 13 and 1 by 3 days. But here we get 6 5 is 30, we get 120 days. 120 days to plant the entire garden when we have a devil and a saint together working on something. Okay, so this is an extra concept which I have taught here. Okay, this is an extra concept which I have taught here. You will see this coming in the next few questions. Moving ahead. George can do 35% of the total work in 6 days. Jim and George work together to complete a work together. Jim and George together completed a piece of work in 12 days. In how many days would Jim, working alone, complete the entire task? I'll take you through the shortcuts only because they are very relevant for the examination. Firstly, George is only doing 35% of the work in 6 days. I need 100% contribution of George. That means if in 6 days he was just doing 35% of the work, then how many days would it take him to complete 100% of the task? Nothing but simple unitary method. So 5 sevens are 35, 5 20s are, and this makes it 120 upon 7 days. This means George can complete a task in 120 upon 7 days. Similarly, if I go for Jim and George together, they complete a work in 12 days. Now I need to find out what is the efficiency of George. What is the efficiency of Jim? Let's first find out the full work or the total work. The total work is nothing but the LCM. I have the LCM with me. The LCM says 120. 120 and 12 make the LCM of 120. When 120 upon 7 is divided through 120, the efficiency, this is the time and this is the efficiency comes out to be 7. Similarly, when 120 is divided by 12, the efficiency comes out to be 10. So the gap between the two efficiencies is 3, and that gap is that of Jim's efficiencies. Jim has an efficiency of 3. I'll rewrite things. George has an efficiency of 7 and Jim has an efficiency of 3. Now Jim has to alone complete the work. Jim has to alone complete the work. How would that be possible? Jim would have the total work with him and we would divide Jim's efficiencies with it. So 120 divided by 3, which is Jim's efficiency, would give me the answer as 40 days. As 40 days, and that would be my final answer. Okay? Okay? I think it's perfectly fine. If not, please do comment and we'll try to figure things out. Yep, we'll try to figure things out. Moving on. I've mostly talked about only two people working together. There can be a possibility when three variables come together and do some work together. My concept will not change. It's going to remain the same. How come? If A is working, B is working, C is working, and they take X, Y, and Z, the total work is going to remain the same, which is going to be the LCM of X, Y, and Z. The efficiencies are also going to come in the same way. The LCM divided by X, same the LCM divided by Y, and the LCM divided by Z. My efficiencies are going to remain the same. Got it? Cool enough? I'll move on. Reena, Veena, and Vimla can do work in 4 hours, 8 hours, and 12 hours, respectively. In how much time will they finish work? Will they finish the work working together? I'll quickly write down R, Veena, and Vimla. 4 hours, 8 hours, and 12 hours. Yep. So we have Reena, Veena, and Vimla working together in separate times, 4, 8, and 12 hours. Okay. So if they work together, we will have to calculate the LCM of 4, 8, and 12. 12, I think 24. Yep. 24 would be the LCM of 4, 8, and 12. 24 divided by 4 gives me 6 efficiency. 24 divided by 8 gives me 3 efficiency. And 24 divided by 12 gives me 2 efficiencies. These are times and these are efficiencies available to me. In how much time will they finish the work working together? How much time will they finish the work working together? Yep. So I have 24 as my total work. Okay, 24 as my total work, and 6 plus 3 9, 9 plus 2 is 11. 11 as my total efficiency. So 24 upon 11, 11 twos are 22, 22 2 by 11 days. This is going to be the total number of time or the total number of days that all three of them together would work so as to complete the task that they were also doing separately. Got it? Moving on. X can do a piece of work in 14 days. I'll now quickly write down the numbers. Okay, these are the number of days, okay, or time. X is 14, Y can complete the same work in 28 days, and Z can complete the same work in 42 days. Okay, 42 days. In how many days can they work together? Can they complete the work working together? Okay, I need to move to a point where I can find their efficiencies and also find the total work in the middle. I have 14, 28, and 42. Okay, so 14 comes with 7 multiplied by 2. 7 multiplied by 4 makes it 28. Now 7 6 is 42. So I have 4, 4 sevens are 28, 28 threes are. This gives me 84 as my LCM. My LCM is also equal to my total work. Now 84 divided by 4 gives me an efficiency of 6. 84 divided by 28 gives me an efficiency of 3. And 84 divided by 42 gives me an efficiency of 2. Okay. My total work with me is 84. My total efficiency is 6 plus 3 plus 2, which is 11. So this is going to come in the denominator. 84 upon 11 makes it 7. Yep, 7. 77 plus 7 makes it 84. So 7 by 11 days. 7 days and 7 by 11 days. This is going to be the total time that would be taken. Okay. So 7, 7, 11. This is my answer. 7 times 7 by 11. Okay. Moving on. When people work on alternate days, okay, when people work on alternate days, whenever you get this kind of a question that people work on alternate days or they work in 3 days or let's say 4 days, so what happens is, let's assume that only A is working here and then only B is working here, then only A is working here, and then on the fourth day only B is working here. In this manner you cannot calculate the total work being done very easily. So what we do is we try to club the situation. We consider that if two of them are working on 2 days basis, that means club I will club the situation. Okay, I will consider the 2 days to be 1 day, and in the end I will multiply all the results with 2 so as to get my final answer. Similarly, let's assume that they are working on 3 days basis. 1 2 3 4 5 6. Only A is working, only B is working, only C is working, again only A, only B, only C. So I'll club 3 days together and I would consider that to be 1 day. And in the end, I would multiply my result with 3 days. Okay. I will multiply my result in result with 3 days. That's how I will reach my answer when people are working on alternate days or in any arrangement or in any sort of arrangement. Okay. I'll move on. A, B, and C can do a piece of work in 30, 45, and 90 days. Nothing changes, only the intermingling or the interplay between the efficiencies would change, and club we would club the things together. We will club the number of days together so as to ease down on my calculations. Okay, 30, 45, and 90. These are the times. Now, talking about total work is equal to efficiency. Efficiency is 90 over here, which is also the LCM. Okay, no, this is not the efficiency. Total work. Okay, total work is 90. Talking about the efficiencies, 90 divided by 30 gives me 3. 90 divided by 45 gives me 2. 90 divided by 90 gives me 1. These are the efficiencies of A, B, and C separately. A starts the work and is assisted by B and C together on every third day. So just see what's going on. First day, second day, third day, fourth day, fifth day, sixth day, seventh day, eighth day, ninth day. On the first day, A is doing alone. On the second day, A is also doing alone. A is again doing alone. third day ABC. Similarly, A, ABC, A, ABC. I can see that the pattern is repeating itself after every third day, right? The pattern is repeating itself after every third day. Just look at it in this manner. Every third day, the pattern is repeating itself. So, what I'll do is I'll club the efficiencies of 3 days together. In 3 days' time, A is working, right? A is working. How? It's working with three efficiency here, three efficiency here. On the third day, A is working with his team. The efficiency of the team is 3 plus 2 plus 1. So the total efficiency of 3 days together is 3 plus 3 6, 6 plus 3 is 9, 9 plus 3 is 12. So 12 is the efficiency. 12 is the efficiency with which they are working. Now I'll consider that they are only working with 12 efficiency in one day. Okay, this would help my cause very well. I'll tell you how. I'll tell you how. I have 90, which is the total work. I have the total efficiency of that of 12. If I divide it, I reach a point where 12 sevens are 84. Okay, 12 sevens are 84. Now the work which is left behind is only 6. Is only 6. As 7 work was done in clubbing nature, if the work of 7 days was done in clubbing nature, and I decided that one day is equal to 3 real days, then 7 days work is nothing but 21 days work. Okay, so I have my answer as 21 right now. 21 is my answer, which is in my back pocket. I will bring it back. I'll show you how. 21 is here. 21 days is my first answer, which is in my back pocket. Now, 6 units of work is left. 6 unit of work is left, and on the day, on the 21st day, A, B, and C had already done their work. On the 22nd day, the series is going to repeat itself. On the 22nd day, A is going to work alone. Okay, and he is going to contribute the efficiency of 3. The pending efficiency is that of 6. The pending work is 6 units, and A is contributing on the 22nd day his efficiency of that of 3. Again, on the 23rd day, A is going to work alone. Why? Because in a series of 3 days each, on a series of 3 days, the couple or the trio work together. 3 people work together. On the 23rd day as well, A is going to work alone, and he is again going to supply his efficiency of 3. The efficiency which I was lacking was 6. The efficiency of 6 was gained in 2 days. How? It was gained in 2 days by A working alone on the 22nd day and A again working alone on the 23rd day. So, this tells me that the entire work was completed in 2 more days. I already have 21 with me and I will add 2 to it. This means it took 23 days to complete the job. Sorted? Very well sorted. It took 23 days to complete the job. This is the only catch that you have to look for. The efficiency might not completely cancel out the total work. In that situation, stop yourself a little short and then do the manual work. This manual work might seem a little daunting to you. Okay? This manual work might seem a little daunting to you, but this is the only way in which you will gain 100% confidence. You'll gain 100% accuracy as well. Do not shirk away from the manual labor. Do not do it. Okay? Let there be a little manual labor. All the questions cannot be solved with the help of shortcuts. Right? I'll move on. Again, they are working together. I have 20, I have 30, I have 60. Okay? I have A, B, and C. A works daily and B and C, yeah, Every third day B and C come. I'll quickly write the LCM. LCM is 60. 60 divided by 20 is 3. 60 divided by 30, this is 2. And 60 divided by 60 is 1. These are the efficiencies. These are the times. This is the total work. Now, every third day, the pattern is going to be the same. 1, 2, 3, 4, 5, 6. I'm just writing it right now, okay? Need not write it that way. A is working daily. B and C are only working on every third day. Okay, this is B and C coming on the third day, B and C coming on the third day. This creates a couple or a trio of 3 days. So I'll consider 3 days, 3 real days to be 1 day, and the total efficiency per day, as was here, 3 plus 3 plus 3 is 9, 9 plus 3 is 12. This is 1 day, and 1 day would have 12 efficiency. If 12 efficiency is being supplied on a virtual 1 day basis, this means the total work of 60 would be done with the 12 efficiency, and it would give me 5 days of work. In 5 days, the entire work is going to get completed, but this 5 days is not the complete answer, because I have assumed that one virtual day is equal to 3 real days. This 5 days is nothing but 5 virtual days. 5 virtual days need to be multiplied by 3 to get the real days. The real number of days is 15 days. Okay, I hope we are sorted. I hope we are good. Yep. Okay, let's move on. Now, talking about when two people are grouped together. Working together, A and B can do a job in 40 days, B and C in 36 days, and all three together can work in 24 days. See, the questions are always going to follow the most standard concept, and this entire chapter has its foundation based on LCMs only. You need not worry. I'll quickly do it for you. A, B are working together, B, C are working together, and A, B, and C are also working together. Okay? The days will not help you at any cost, neither would total time help you. The only thing that will help you would be the efficiencies. Why would efficiencies help you? Because our efficiencies are directly related. You can easily give them numbers. Okay, you can easily have a numerical value to the efficiency, and you can with guarantee say that this guy has this efficiency. But when you talk about days, it complicates the situation. It complicates the situation, right? I'll tell you how now. AB take 40, BC take 36. All of them take together 24, right? All of them take together 24. The LCM I can see over here is 120. 43 is a 120. 36, no, 120 is not the LCM. 180, no. 360 is the LCM. I made a very small mistake. I made a very small mistake. No problem. The 360 is the LCM. 40 9s are 360. 36 10s are 360. 24 15s are I don't know. Wait, yeah, 15s are 24 15s are 360. We have 360 as our LCM, and this is nothing but our total work. In how many days can B alone do the job? In how many days can B alone do the job? I really want you to work it out on your own this time. Okay, just give me a 20-second time, and during that time, kindly solve the question yourself. 20 seconds only. Yep. Yep. I'm good. So let's go ahead. See, simple linear equation solving helps me out in this way. A plus B is equal to 9. I cannot say A plus B is equal to 40 days, but I can say that A plus B is equal to 9. B plus C is equal to 10. A plus B plus C is equal to 15. A plus B plus C is equal to 15. Now I need to find out the value of B from these three equations. I have three equations, I have three variables. I'll quickly find out the value of b. If I add these two together, I get the answer as a plus b, which is nothing but twice of b. Okay, I'll write it down in bracket. Plus c is equal to 19. This is a plus twice of b plus c. But the value of a plus b plus c is already equal to 15. This is a plus b plus c, and I already have the value as 15. If I subtract both of them, I'll get the value of b only, which is nothing but 4. The value of 4, what I'm getting over here, is nothing but the efficiency of 4. If the total work, if the total work is falling off to be 360, and the efficiency of b is only required, which is equal to 4, then I can say that b alone would finish off his work in 360 upon 4, which is 90 days. Which is 90 days. Got it? Minus has been done over here. It's not a tough, it's not at all a tough chapter. It's very easy. You just need to have, you just hold on to LCM in this entire chapter and you'll do wonders yourself. Okay? Coming down to this, Mahesh, Suresh, and Raju together can complete a work in 18 days. Mahesh, Suresh, and Raju. Okay, this is M plus S plus Raju can complete a work in 18 days. Suresh and Mahesh, or Mahesh and Suresh, can together complete this work in 72 hours. Raju alone can do it in how many hours is my question. I'll quickly find out the LCM. The LCM of this equation is 72. 72 divided by 18 is 4. 72 divided by 17 is 1. These are the efficiencies. I can easily play along with efficiencies, right? Through this, I can quickly say that Mahesh plus Suresh plus Raju together have an efficiency of 4, and Suresh plus Mahesh have an efficiency of 1. Through this equation, I can easily say that Ramesh, or sorry, Raju's efficiency is nothing but 3. Raju's efficiency is nothing but 3. I need to have my total work. My total work was already found out over here during the LCM. The total work is 72, and 3 is the efficiency of Raju. So this would give me Raju's days, Raju's days to be 24 days, right? And which is my final answer. See, this was a little complicated looking question, but it was done in a jiffy. No problem at all. So you have to become this smooth. Okay, moving on. When people leave or join in the middle of work, I've already talked about it. If they join in the middle or leave in the middle, what sort of operations you need to perform? A, B, and C can do a work separately in 6, 10, and 15 days. Okay, these are A, B, and C. They can do a work separately in 6, 10, and 15 days. I'll quickly use the LCM method and try to find out the total work. When the total work is there, we can also pull out the efficiencies, and efficiencies come out to be 5, 3, and 2. Okay, these are the efficiencies. E double F double F, EF, EF, and EF, and these are the days. Now, they started working together, but C left after 2 days. C left after 2 days. That means the total work was 30. If C left after 2 days and he has already gone, that means we need to take out the time that C invested with everybody. We need to take out the time, or we have to take out the efficiency, or the amount of work which C did in 2 days. The efficiency of C was 2, and he worked for 2 days. This means that he contributed to 4 units of work. He contributed to 4 units of work. If all are there and total work is being performed, and we need to separate out the work of C, whatever would be left behind was done only by A and B, right? The total work is here 30. 30 minus 4 gives me 26. 30 minus 4 give me 26. Now This 26 work would be done only by A and B because C has already contributed his share and left. So 26 would be divided by the efficiency of A and B, which is nothing but 5 plus 3, which is equal to 8. So this gives me 3 2 by 8 or 3 1 by 4 days. This is the time that this is the way in which the remaining work would be finished off. Okay, I hope I've made myself very clear with this. Moving on. A and B can do a piece of work in 18 and 36 days respectively. I'll quickly write it down here. A and B, 18 and 36. Total work, I know you're pretty good at it now. 36 upon 18 is 2 and 36 upon 36 is 1. Here we are sitting at efficiencies and here we have days. In the center we have total work, right? They start working together but A leaves after 3 days. 36 was the total work. I need to subtract I need to subtract the days which were spent by A. 2 multiplied by 3 which is equal to 6. This gives me 30, right? 2 multiplied by 3, this gives me 30. They start working together but A leaves after 3 days. A leaves after 3 days. These are the number of days they are leaving and this is the efficiency of A. Okay, this is the efficiency of A. So 30 is the remaining work which needs to be completed by B alone. Okay, which needs to be completed by B alone. 30 divided by what? B alone. The efficiency of B is 1. 30 is the remaining work. 30 divided by 1 gives me 30. This is my answer. So 30 days is going to be the remaining time which B would alone take to complete the job. Got it? Moving on. Now efficiency is given and in form of days. You need not worry about the concept that is written. Focus on the questions. A can do as much work in 4 days as B can do in 5 days, and B can do as much work in 6 days as C can do in 7 days. So we are going to now work on relative quantities. See how I'll do it. Okay. So A's 4 days work is equal to B's 5 days work, and B's 6 days work is equal to C's 7 days work. See how smartly we'll play now. We need to have a common number within B so that the equation streamlines into one entire line. How would that happen? I need to make the coefficient of B equal in both the different equations. Okay, this was equation 1, this is equation 2. If I multiply 6 with 15, if I multiply 6 with 15 with 5, I would get 30x 30b, 30 times b. Now if 6 is multiplied by 5, because of the equality principle, 6 would also be multiplied by 4. This would give me 24a. So 24a is equal to 30b. Now 5 is now going to get multiplied with 6. Okay, this would make it 30b, which we already have in the equation, or let me write it again, 30b. And this 5 would also be multiplied to 7. This gives me 35c. Now if I wish to streamline the situation, what I get out of it is 24a is equal to 30b is equal to 35c. 24a is equal to 30b is equal to 35c. Okay, I have gotten this value with me. Now this means that 24 days of A's work is equal to 30 days of B's work is equal to 35 days of C's work. Right? We are good to go. Now the question says, in what time will C do a piece of work which A can do in 7 days? I'll only and only focus on A and B, A and C from this equation. It says 24 days of A's work is equal to 35 days of C's work. Okay, this means A upon C's efficiency is 35 upon 24. Now, if A is doing something in a week, if A is doing something in a week, then how long will C take to complete the same work? A's 35 days work is equal to C's 24 days work. I need to divide it in the numerator as well as the denominator by 7. No, by 5. Because I need to have 7 days of A's work is equal to X days of C's work. If I use the value of A as 35 multiplied by 7, I will have to find out X multiplied by 24. But this doesn't make much sense. So what can be done over here is, just give me a moment. Just give me a moment. If I have the value of A by 7, then I have to find out C upon X. To make A's efficiency, or the number of days A is working, 7, I need to divide both sides by 5. 5 in the numerator as well as 5 in the denominator. I'll use 5 ones are here, 5 sevens are. Now 24 would also need to be divided by 5. 24 would need to be divided by 5. 24 upon 5 is nothing but 4.8. So 4.8 days is my final answer. C would do the work in 4.8 days, which would take A 7 days to do. Okay, I hope you've understood. All right, moving on. So we have this question with us. Shreyas can complete 4 by 5th part of a work in 16 days. Ruchi is 2.5 times as efficient as Shreyas. In how many days will Ruchi alone complete the same work? We have Shreyas and we have Ruchi. We'll first move from efficiency to the number of days they take to complete the work. Firstly, I need to have a clear idea in how much time can Shreyas complete the entire work. We are talking about 4 by 5th part of the work being done in 16 days. If 16 days can if 16 days can complete only 4 part of the work, what about the 5th or the complete part of the work? This is going to be 20. So 20 days is the total time Shreyas takes to complete the entire work. This is established. Okay. By now, I need not. By now, I need not talk about anything else. Okay. Anything else? I shouldn't be more focused on creating this 16 to 20, because this is very much doable already. So we are not going to spend a lot of time in moving from 4 by 5 to 16 to 20. So we're very clear that Shreyas completed his part in 20 days, the entire work in 20 days. Ruchi is 2.5 times as efficient as Shreyas. Okay. Now talking about efficiency. The efficiency, the days are inversely proportional to the efficiency, and the efficiency are inversely proportional to the days in which the work is completed. So efficiency and days. Ruchi is 2.5 times more efficient as Shreyas. If the efficiency of Shreyas is 2, Ruchi's efficiency is 5. 2.5 times more. Okay, 2.5 times as efficient. So 2 multiplied by 2.5 means 5. This is established. 2 and 2.5. 2 and 5 is established. Now, if 2 is inversely proportional to 1 by 20, 2 is inversely proportional to 1 by 20, or if 2 is inversely proportional to 1 by 20, 5 would be proportional to what? 5 would be proportional to what? This 1 by 20 can be written as, here, here, we'll have to make a very small assumption. We will have to make a very small assumption. And the assumption says that the LCM is 40. If 40 is divided by 20, then the efficiency comes out to be 2. Then the number of days of R need to be what so as to get the efficiency as 5. This means this would have been 8, because 40 divided by x needs to be 5. So 40 upon 5 is also equal to x, and the value of x is nothing but 8. It means Ruchi takes 8 days alone to complete the entire task. And that was my final answer. That was my final answer. Got it? Got it? This could have also been done in another way. The efficiency of Shreyas was 2, the efficiency of Ruchi was 5, and the number of days for Shreyas was 40, and the efficiency and the number of days for Ruchi was x. Okay? These are days and these are efficiencies. As efficiency is inversely proportional to days, as efficiency is inversely proportional to the number of days 1 upon days, that's how efficiency is equal to k upon days. Efficiency is equal to k upon days. Efficiency is 2. The value of k needs to be found out, and the number of days is 20. I by mistake wrote 40. Okay, so this is 20. So the value of k comes out to be 40. Similarly, here, if I apply it for Ruchi, this was for this was for Shreyas. If I try to find it out for Ruchi, the efficiency is 5, the value of k is 40, and x is the number of days. In this manner, the value of x would come out to be 8 days. Okay, the value of x would come out to be 8 days. I hope I'm good, really good. Moving on. Efficiency is given in the form of percentages. Here, efficiency was given in form of ratios. In the next portion, we'll get efficiencies in form of percentages. Okay, A and B can together do a piece of work in 50 days. If A is 40% less efficient than B, this means the efficiency of B is assuming to be 100%, and A is 40% less efficient. 40% less efficient means the efficiency of A is 60 when compared to B's efficiency, which is 100. And we're talking about efficiency only. Let me put it down to fractions. This means the efficiency ratio of A and B is 3 is to 5, right? So in how many days can A efficient than B? In how many days can A complete 50% of the work? Okay, let me just figure out the question. In how many days can A do 60% of the work? See, the question is pretty clear. In how many days can I'll cut it off, can A do 60% of the work? Okay, 60% of the work. Now I have these efficiencies with me. Now, together they are completing a task in 50 days. That means 50 days A and B are working together. This means in terms of units, 50 multiplied by 3 plus 5 is the total work being done by them. Okay, this is equal to the total work, which is also equal to 400 units of work. Now, how many days can A complete 60% of the work? First, let me find out 60% of the work. 60% of 400 is 240 units. 60% of 400 is 240 units. And this 240 units needs to be dealt with. This is the work which is remaining, or the work that only A is supposed to do. That means the efficiency of A would be divided by the total work which is supposed to be done. So, so 240 would be divided by 240 would be divided by efficiency of A, which is nothing but 240 upon 3, which is equal to 80 days. Okay. So it's going to take A 80 days to complete 60% of the work of the same work which they were doing together in 50 days. I hope I'm clear. Moving on. A alone can complete a work in 20 days with full efficiency. Okay. A alone can complete a work in 20 days with full efficiency. We are increasing the speed. We are hardly left with around 5 or 6 more questions. We're doing them more quickly because we're coming along working, and we're coming along after learning many things. Okay. So the same concept would not be taught multiple times. So please bear with the speed. Okay. Run along with us. A alone can complete a work in 20 days in full efficiency if the efficiency of A decreases by 20%. Okay. Efficiency of A then versus A now. Okay, this is A then, and this is A now. The efficiency has decreased by 20%. It means he was working with full 100% efficiency here. Now the new efficiency has become 80%. I'll quickly put it down to fractions. The efficiency has become 5 is to 4 as compared to the old guy versus the new guy. If 20 days were being taken by A back then how many number of days would be taken by A now to complete the job? So 20 multiplied by the A then, or the efficiency of A then, should be equal to X multiplied by efficiency of A now. So 20 multiplied by A then is 5, multiplied by X multiplied by A now is 4. So 4 ones are 4 fives are. So the value of X comes out to be 25 days. Right? I hope we're good. Moving on. Now efficiency is given in the form of ratios. We've already dealt with it. We'll quickly see the question. The ratios of the efficiencies of A, B, and C are 7 is to 5 is to 8. Working together, they can complete a piece of work in 42 days. B and C, if they are working together and they are taking 42 days time, that means 42 times multiplied by the efficiency of A plus efficiency of B plus efficiency of C. And these are nothing but efficiencies only. 7 is to 5 is to 8 are the ratios of the efficiencies. This can be called the total work. Now, B and C have worked together for 21 days and the remaining work was completed by A alone. We are supposed to focus only on the remaining work. We are supposed to focus only on the remaining work. What does the remaining work talk about? 42 multiplied by the total work. Let me quickly find out the total work. EA, EB, and EC. When I add all of them up, this comes out to be what? 20. So this is 840. 840 is the total work. Now, B and C have worked together. B and C with a total efficiency of 5 plus 8 are equal to 13 efficiency. With the help of the 13 efficiency, they have worked for 21 days. So 13 efficiency multiplied by 21 days is the work done by B plus C. What is the value of this work done by B plus C? 13 ones are 13, 13 twos are 26, 27. 273 work has already been done by B and C. What is the work left? Work left is equal to 840 minus 273. This would give me a 7. This would give me a 6. And 7 minus 2 is 5. So 567 is the work that is left. 567 is the total work that is left. This 567 would be completed by A alone. So the work that is left, the work that is left divided by A, the work that is left divided by efficiency of A is my answer. Work left is 567. The efficiency of A is 7, very clearly mentioned. This gives me the time taken by A alone to finish the work as 81 days. The question says the whole work was completed in how much time? We have 81 days with us, which is the clear answer, but it is not the final answer. 81 days needs to be added with 21 days for which B and C work together. This gives me an answer of 102 or 102 days. So, wherever you find 102 days as the answer, that would be the final answer. Good enough? Let's move on. When A and B take X and Y days extra than A plus B, okay? They take extra days than A plus B. There is a concept that A plus B have done some work in, let's say, P number of days. They have worked together. They have worked together. But if one of them alone goes to work, he's going to take more time as compared to them together, because when two people work together, they do the job faster. Okay, they do the job faster when two people work together. But they would do the work in, like, the number would be a little higher than the one which was done previously. So if A and B together can complete a work in P days, and A alone does the job in P plus X days, and B alone does the same job in P plus Y days, and you are asked what is the time that A and B took to complete the job, which is P. So the value of P would come out as root of X multiplied by, okay, root of X multiplied by Y would be the answer. Okay, this is another rote formula which you must learn, and this is the most standard point, and it is also one of the most asked questions in SSC's history. Okay, coming to the question. A works alone. He would take 4 more days to complete the job than if both A and B work together. Let's assume that A and B work together. A and B work together and they took X hours to complete the job. It says that A took X plus 4 more days to complete the work. And B also worked alone. B also worked alone. He took X plus 16 more days to complete the work. So, how many times would they take together to complete the work if both of them work together? It means they are asking the value of X. If they are asking the value of X in such a question, the value of X, as explained in the previous formula, is nothing but root of 4 multiplied by 16. Right? In the root 4 multiplied by 16, this gives me 2 into 4, 8. So the value of X comes out to be 8. And 8 is the time, or 8 is the number of days they would take to complete the work together. Got it? Simple enough. Such a long question, such an easy explanation. Cool. Moving on. When A alone does a piece of work, he takes 25 days more than A and B together. Same way, okay? A plus B are taking X days, and A alone took 25 plus X. Similarly, B also took 16 plus X. They're asking the value of x. The value of x would be the under root of 25 multiplied by 16. This is 5 4. 5 fours are 20. So the value of x comes out to be 20. Right? Let's move on. Now, we talk about when days and efficiencies are given. And this is also a concept of wages. This is also a concept of wages. The most important point when wages are discussed is that the wages are distributed. The wages are distributed in terms of efficiencies. The wages are distributed in terms of efficiencies only. Got it? Got it? Let's move on. Three laborers A, B, and C were given a contract of 750 rupees for doing a certain piece of work. All the three together can finish the work in 8 days. A and C can together do it in 12 days, while A plus B can do it in 13 and a half days. The money would be divided in what ratio? We need not focus on 750 rupees, we just need to focus on the efficiencies of all of them alone. Okay, so I'll quickly write down the number of days they can work together and how in what manner they can work together. I'm writing A plus B plus C. They doing the work in 8 days. A plus C doing it in 12 days, while A plus B doing in 13 and a half days. Instead of writing it 13 and a half, let me write it as 27 by 2. Now, the tough part might be to find out the LCM. I'll quickly write down 8 here. 2 multiplied by 2 multiplied by 2 multiplied by 3 gives me 12, and I need to get a 9, like what? 9 threes are 27. I need to get 3 nines. So we have 27, 27 into 8. Okay, or we could have 6 into 6 into 6, which is equal to 216. 216, right? So 216 is my 216 is what? 216 is my total work. Now 8 twos are 16, 8 sevens are 56, 12 ones are 12, 12 eights are 96, 27 eights are 216, but 27 upon 2 is there. That means it will come out to be 16. Okay, now I need to find out their efficiencies separately. If I add up these two equations, I get the value of twice of A plus B plus C to be 34. If I have only these three equations, A plus B plus C comes out to be 27. I quickly divide all of them. I get the value of 7 over here, and I get the value of 2 times of A. So this means, sorry, no, I don't get the value of 2 times of A. I get the value of A as 1. Sorry, A as 7. So the efficiency of A is simply 7. If I put that back in the first equation, I'm marking this as the first equation, I get the efficiency of C to be 11. Similarly, I wish to talk about B as well. I use the efficiency of 7 in the second equation. I'm calling this the second equation, which gives me the equation of B, or which gives me the efficiency of B equal to 9. So from this area, I can say that the ratio or the way in which the money would be divided would be 7 is to 9 is to 11. This is for A, this is for B, and this is for C. Right? This is for A, this is for B, this is for C. Good enough. Let's move on. Arun alone can do a piece of work in 6 days, and Selvi alone can do the same work in 8 days. Arun and Selvi undertook it for 7,200 rupees. With the help of Kevin, they completed the work in 3 days. So I have Arun, I have Selvin, then I have a company of three people, A, S, and K, because Kevin also came into the picture. Along with Kevin, they did it in three. They alone were doing it in 6 and 8. They alone were doing it in 6 and 8. So I'll quickly take the LCM. The LCM comes out to be 24, and the efficiencies are 4, 3, sorry, and 8. 4, 3, and 8. Somebody asks me their efficiencies separately. This is A, S, and K. I have the efficiency of A as 4, S as 3, and the efficiency of K as 1. Okay. I quickly did the unitary method and found out the value of K. These are the efficiencies. This is the number of days, and this is the total work. So I have these efficiencies with me. The total work was this entire efficiencies. This was supposed to be paid 7,200 rupees. 7,200 rupees was supposed to be paid to them. Now, how much is supposed to be paid to Kevin? How much is supposed to be paid to Kevin? If I see out of this, the total is 8. The total is 8. Out of 8, only one portion has to be given to Kevin. So 1 by 8 times of 7,200 would be my answer, because Kevin is supposed to be given only one portion out of a total number of 8 portions. So 8 nines are 72, and 900 rupees is the money that Kevin would take home. Right? Now, there's another concept of when people work and when people join. Okay? So A can complete a task in 12 days, B can complete a task in 18 days. When they start working together, A works only for 2 days. The remaining work is completed by B. Okay, the remaining work is completed by B. So we'll see how much was the efficiency used. For how many days was the efficiency used? So this is my main point. This is my main point. A can complete a task in 12 days. B can complete a task in 18 days. They start working together, but A works only for 2 days. Let me quickly find out the LCM. The LCM is 36. The efficiency of A is 3. The efficiency of B is 2. Okay, these are efficiencies, these are days, and this is total work. Let's assume they started working together. A plus B were working together. A plus B were again working together. A contributed his efficiency of 3 only 2 times, but B was working all day long. Okay, B was working all day long. After that, B was left and B finished the job. Let's assume 5 was the total contribution on the first day, 5 was the total contribution on the second day. So total 10 work has already been done, and 16 work needs to be done. 16 work is pending. No, not 16, 26. 26 units of work is pending, because these two become 10 units of work. 26 units of work is pending. This 26 units of work would be done by B alone, and the efficiency of B is 2. So for 13 days, the efficiency of B is going to be used. Now the total wages are 2,400. A worked for 2 days with 3 efficiency, and B worked for 13 plus 2, 15 days with 2 efficiency. Okay? Okay? How much they worked, with what efficiency they worked, and for how long they worked. 2 and 2 get cancelled. 3 ones are 3, and 3 fives are 15. So the money in which, or the way in which the money would be distributed would be 1 is to 5. Right? The wage was 2,400, and B gets 5 shares of it out of a total number of 6 shares. Out of a total number of 6 shares, B gets 5 shares. So 6 ones are 6, 6 fours are 24. Okay, 6 ones are 6, 6 fours are 24, and we get 400 here. So 5 fours are 20. So 2,000 rupees is what B would take. Got it? 2000 rupees would be the money B would take home. Moving to the last question, moving to the last and the very last question. X can do a work in 15 days alone. Y can do it alone in 10 days. They've worked together for 3 days and the remaining work is finished by Z in 1 day. Okay? I'll focus on this later. I'll first focus on this. 30 is the total work, 15 2 is a 30 and 10 3 is a 30. These are the efficiencies, these are the days and this is total work. They worked for 3 days. X and Y worked for 3 days. They were contributing 5 and they worked for 3 days. That means they gave 15 units of work. Now, 15 units of work was given by them. Total work minus 15 units gives me 15 balance. So the 15 balance was done by Z in 1 day. This means Z's efficiency is 15 units per day. Okay. Meanwhile, X and Y were contributing 2 units per day and 3 units per day. But when Z came into the picture, he did 15 units of work in 1 day. Now the question is, if they are paid 4,000 rupees for the entire work, then what is the share of Z? There are 3 people who have worked. X has worked for 3 days, Y has worked for 3 days, and Z has worked for 1 day. The efficiency of Z was 15 multiplied by 1. This is in terms of wages, okay? I know that you're definitely understanding whatever is going on. Y is multiplied by 3. Y's efficiency was 3. So 3 into 3 is 9, right? So 3 is here. X's efficiency was 2. So 2 multiplied by 3. This output would come out to be 2 is to 3 is to 5. 2 is to 3 is to 5. Now this is the manner in which the manner in which the entire shares would be split. They are talking about the shares of Z. This is X, this is Y, and this is Z. If you have Z in place, if you have Z in place, then the share of Z is 5 with a total work of X, Y, and Z being equal to 10. 5 by 10. 5 ones are 5, 5 twos are 10. So this means half of the share would be given. Half would be multiplied by the 4,000 rupees of which was the total wage or the total payment that was given to them. This is nothing but 2,000 rupees, which is my final answer. 2,000 rupees would be paid to Z because he was very efficient, and the rest of the money would be distributed among X and Y. According to what proportions? 2 is to 3 times. Right? Right? It means 600 rupees would go to Y and 400 rupees would go to Z. No, 1200 rupees would go to Y and 800 rupees would go to X. Right? I'll take you back to the first class, to the first point, to the first slide. Okay? Because I believe the first slide was enough for you to understand the entire chapter. LCM method we have gone through. The thing which comes out here in the center is the total work. The LCM is nothing but the total work. In basic proportionality, I've talked about MDH masale. Okay, my masale are nothing but a concoction of spices. So MDH is equal to MDH. Then linear equation method and an OR method. When multiple groups of people work together, we are supposed to only look at simple linear equations there. Then talking about efficiency method, the time is inversely proportional to the efficiency. Why? Because the more time you take, the less efficient you are. The less time you take, the more efficient you are to complete a job. Okay, so I believe we've done it completely. Whatever questions you may have, please drop them in the comments. Thank you.